Good evening, everyone. Welcome to Mr. Dwight Doodles again. This little showcase of how-to is regarding microscopy and the magnification equation. You've all been given these to do over half term. So what I'm going to do is quickly go through the knowledge required of a microscope, and then also provide you with a worked example of how to answer a very challenging magnification equation. So this is a light microscope. What happens is you turn it on, light passes up through a lens, and it passes up through a further lens, which is called the eyepiece lens. This generally has a magnification of times 10. And then you have these things. These are called the objective lens because you can change them. And these range from times 4, times 10, and times 40. Therefore, you look down the lens and you're looking down through the times 4 of the objective lens. It's 10 times 4 to give you a total magnification of 40. 10 times 10, 100. 10 times 40, 400. If you use the ones at school, generally the ones that are 10 times 40, they need refurbishing, and so they're a bit blurry, so we can't use those ones. The microscope magnifies. It makes a small image much larger. The word that you cannot use is zoom. If you want to change the magnification, you change the objective lens to a more powerful lens. We then come down to these. We've got the fine and the coarse adjustment knobs. And what do they actually do? Well, when you turn the fine and coarse adjustment knob, these two things deal with something called focus. Focus is the clarity or how clear the specimen seems. And all they do is they move the stage up and down in order to focus the image, because everyone's eyesight is different. To change the magnification, you change the objective lens to a more powerful lens. When it comes to focus or resolution, how clear is the image, you change the coarse or the fine focus knob, and it moves the stage up or down, closer to the objective lens or further away from the objective lens. And therefore we have this thing here called a stage. That is the description of how a microscope works. That's taken all of a minute and a bit. So now we move on to how we prepare a slide, or when we put a slide on. And when we use a microscope, we always begin with times 4 objective lens. This means that when we put our specimen onto the slide, if we were to compare it to times 40, this is not to scale, by the way. When you look through the eyepiece lens and through the objective lens, by using a smaller magnification of a total of 40, you're able to find where the specimen is, because the specimen is much larger, so it has what we call a wider field of view. But if you were to start on 40 times 10, 400, the specimen may be so small, this is 400 magnification, that you may be looking here, 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 and you've yet to find the specimen. So we always start on the smallest magnification, change the magnification once you've found your specimen in the widest field of view, and then you change the objective lens. Okay, let's have a look at what a question looks like before you attempt these questions. So this is the biological equation that you do need to know. And the biological equation is I am. It's probably the easiest way to remember it. There's the divide, there's the times. What do these mean? This one here is the image. This one here is the actual. That's the real size of the specimen. And this one here is the magnification. This is knowledge that you do need to know. Right, you need to be armed with a ruler when you do these some of the time, because some of the time you will need to measure the distance between X and Y. So we have a root hair viewed using a microscope. Root hair was viewed at a magnification of times 50. Image length of the root hair is X to Y is 43 millimeters. Calculate the real length of the root hair in micrometers. So, as within physics, guess method. G, given, what have I got? I've got magnification. I've got image. U is unknown. What is the unknown? What is it I have to calculate? This is the real. Real is AKA actual. What is the equation? Well, then all we have to do is put the numbers into the simplest form of the equation. So we have image. An image is, on the paper, from there to there is 43 millimeters. So 43 divided by magnification 50. However, it does say we need this in micrometers. So therefore, the millimeters of 43 times 1000 would be 43,000 divided by 50. And that would give you the answer. In this packet of work, you have further examples for you to do. There's a description of how to use a microscope. This one asks you when the eyepiece is not 10, it's 5. We then have a very challenging question where you have to use the description of using a microscope in order to calculate a mean. Another calculation question. Another calculation question that is rather challenging. And then at the back is you have the mark scheme. So firstly, I'd like you to watch the video. Once you've watched the video, pause it, have a go at the questions. If anything becomes troublesome or challenging, review back to the video and then mark your work using the mark scheme. Thank you.